Hi, welcome to Pathways to Chemistry. This is Dr. O'Connor, and here we're asked to calculate the molar mass of a gas that is at 388 torr, 45 degrees Celsius, and 206 nanograms of this gas occupies a volume of 0.206 microliters. Well, let's first, obviously this is an ideal gas law problem. So let's write out the ideal gas law. And we have pressure times the volume equals the number of moles times the ideal gas constant times the temperature in Kelvin. So we're being asked for the molar mass. Recall that N, the number of moles, that would be equivalent to the mass in grams divided by the molar mass. So we can substitute this in to the ideal gas law for N, or the number of moles. So let me go ahead and rewrite the equation. And that's going to be the mass in grams times R times T divided by the molar mass. So now let's go ahead and rearrange the equation and solve for molar mass. So what we have is the molar mass is equal to the mass of the gas in grams times R times T divided by the pressure and volume. Okay, so this is the equation that we're going to use. Now, let's look at what we're given here. I'm going to use the ideal gas constant of R equal to 0.0821 liters times atmosphere per mole per Kelvin. Okay, that's the one I'm going to use. So that means that all of my units here have to be in units of atmospheres. I need grams, liters, and so on. So we need to convert the pressure. So the pressure is equal to 388 torr, and we need to convert that to atmospheres. And we know that 1 atmosphere is 760 torr. So let's see, that's going to give us 0.51053 atmospheres. Okay, so let's go ahead and convert our temperature to Kelvin. So that's 45 degrees Celsius plus 273.15. And that's going to give us 318 Kelvin. Now I need to convert the mass to grams. So 206 nanograms, and we know that 1 nanogram is 10 to the negative 9 grams. So that's going to give us 2.06 times 10 to the negative 7 grams. And then finally we need to convert volume to liters. So volume, we have 0.206 microliters, and we know that 1 microliter is 10 to the negative 6 liters, and that gives us 2.06 times 10 to the negative 7 liters. Okay, so everything's converted. We have the appropriate units, so now we just go ahead and plug these values into our equation here. Our molar mass then is equal to the mass in grams, which is 2.06 times 10 to the negative 7 grams. And we multiply that by R, 0.0821 liters, atmospheres per mole per Kelvin. And then we multiply that by the temperature, which is 318 Kelvin. And then we have to divide all of this by the pressure and volumes. The pressure is 0.51053 atmospheres, and then our volume is 2.06 times 10 to the negative 7 liters. Now, I'm going to make sure that my units cancel so that I get my desired units, which of course is grams per mole, which is the molar mass. So atmospheres cancel, and liters cancel, and Kelvin, it cancels, And sure enough, I'm left in grams per mole. So I go ahead and plug this into my calculator, and I end up with 51.1 grams per mole. So this was a nice example of how we can determine molar mass using the ideal gas law.